Once the James Webb Space Telescope was launched, the anticipation was high for it to reveal the mystery surrounding the Big Bang and uncover previously unidentified celestial bodies. However, the scientific community was taken aback by its latest groundbreaking discovery. Renowned astrophysicist Michio Kaku went as far as to claim that this revelation not only merits a Nobel Prize but also poses a potential threat to the very existence of the universe itself. The question arises, what exactly is this shocking discovery, and are new laws of physics required to expound these baffling phenomena? Join us as we explore the latest discovery of the James Webb Telescope that could potentially alter our understanding of the universe. The James Webb Telescope is not only humanity's most sophisticated instrument for space exploration but also one of NASA's most expensive science projects to date. With an extensive construction period of over 2 decades and a staggering budget of $10 billion, this telescope has captured the attention and respect of the scientific community. Recently, it has made a groundbreaking discovery that has left the world in awe. It transmitted the first concrete evidence of a black hole. What's even more shocking is that this massive black hole is not alone but rather connected to something that scientists have likened to the reset button of the universe. Before delving into the implications of this astounding revelation for our solar system, let us take a closer look at this momentous discovery. The James Webb Space Telescope, JWST, was designed to succeed the Hubble Space Telescope. Its primary goal is to observe the universe in infrared light, allowing it to see through dust and observe objects that are too faint or distant for other telescopes to detect. The JWST has several scientific objectives, including studying the formation and evolution of galaxies, observing distant objects in the early universe, investigating the atmospheres of exoplanets, and studying the formation of stars and planetary systems. One of the key features of the James Webb Space Telescope is its large primary mirror, which is 6.5 meters, 21 feet, in diameter and is made up of 18 hexagonal segments. This large mirror allows the telescope to collect more light and achieve higher resolution than previous space telescopes. The mirror is also coated with a thin layer of gold to enhance its ability to reflect infrared light. Another important instrument on the James Webb Space Telescope is the Near-Infrared Camera, NIRCam, which is designed to take images of celestial objects in the infrared range. NIRCam is capable of observing objects that are very faint and distant, such as the first galaxies that formed in the early universe. The JWST is also equipped with other scientific instruments, including a near-infrared spectrograph, NIRSpec, for studying the chemical composition of celestial objects, a mid-infrared instrument, MIRI, for observing the formation of stars and planetary systems, and a fine guidance sensor near-infrared imager and slitless spectrograph, FGS-NIRIS, for precise pointing and alignment of the telescope. In terms of its launch and deployment, the JWST is a complex mission. It is a joint project of NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA. The telescope was launched on December 25, 2021, using an Ariane 5 rocket from French Guiana. After its launch, the JWST underwent a series of deployments and maneuvers to reach its final orbit, which is located approximately 1.5 million kilometers, 930,000 miles, from Earth. Considered the successor to the Hubble Space Telescope, the JWST is generating a lot of excitement in the scientific community. People from all over the world are sharing its images and using the raw data to make new discoveries. According to the Space Telescope Science Institute, since its launch, scientists have made many significant discoveries using the telescope. There have been over 750 scientific publications that include a substantial amount of data from the James Webb Space Telescope. Let's take a closer look at some of the exciting findings made by the James Webb Space Telescope so far. In the 1990s, scientists discovered the first exoplanets orbiting distant stars by observing the slight decrease in a star's brightness when a planet passed in front of it. However, the James Webb Space Telescope has revolutionized exoplanet observation. Equipped with advanced instruments, it can directly capture images of exoplanets by blocking out the star's light. Within a year of its launch, the Webb telescope made history by capturing its first direct image of an exoplanet called HIP 6542-6b. This gas giant planet is located 100 times farther from its star than Earth is from the Sun. Webb used multiple filters and cameras to capture images of this massive planet, which were combined to create a composite image. These discoveries not only proved the capabilities of the Webb telescope but also had a profound impact on astronomy. HIP 6542-6b is special because of its size, which is about 12 times that of Jupiter. Its size and distance from its star made it easier to capture an image. However, the significance of direct imaging of exoplanets goes beyond visual appeal. It helps us understand the origins of the universe and the possibility of life beyond our solar system. These images provide insights into planetary formation and exoplanet atmospheres, contributing to the discovery of habitable exoplanets. While habitable exoplanets are currently thought to be rare, the Webb telescope's observation capabilities position it to make groundbreaking discoveries in this cosmos. The images sent by the James Webb Space Telescope have revolutionized our understanding of the universe. The images showed numerous stars and galaxies, with the older galaxies appearing reddish and darker. Researchers from various teams immediately began analyzing these images using advanced computer technologies. Through these state-of-the-art technologies, scientists have been able to extract a wealth of information from each point of light in the images. They determined the age of the light, identified the elements that reflected the light, calculated the speed at which galaxies were moving, and estimated the number of stars within them. But the latest discovery of the James Webb Telescope has been a source of concern for experts, as it is believed to have the capacity to destroy the universe. What is this shocking discovery of James Webb, and why is it so spectacular? The James Webb Space Telescope is a remarkable feat of modern technology. Its images have transported us back in time. Through its observations, researchers made groundbreaking discoveries, including ancient galaxies and a massive black hole with a mass 10 million times greater than our Sun. According to the Big Bang theory, there should have only been prototypes of stars and star collections during that time. However, the James Webb Space Telescope sent images revealing 6 galaxies that were already massive, bright, and filled with stars. What's more interesting is that scientists speculate these galaxies may host supermassive black holes, which have been detected through gravitational lensing. Black holes are incredibly fascinating and mysterious objects in space. They are regions in space where gravity is extremely strong. Gravity is the force that pulls objects toward each other. When a star is very massive, it can undergo a special process called a supernova. During a supernova, the star explodes and throws off its outer layers into space. What's left behind is a dense core, which can collapse under its gravity to form a black hole. A black hole is simply an area in space where this collapsed core has become extremely dense and compact. It's so dense that the gravity it produces is incredibly strong. In fact, the gravity is so intense that nothing, not even light, can escape its pull if it gets too close to the black hole. That's why it's called a black hole, because it doesn't emit or reflect any light. Supermassive black holes, as the name suggests, are incredibly large and can have millions or even billions of times the mass of our Sun. They are thought to exist at the centers of most galaxies, including our own Milky Way galaxy. The boundary around a black hole is called the event horizon. Once an object crosses the event horizon, it's trapped inside the black hole and can never escape. This is why we can't directly see or detect black holes, because they don't emit any light themselves. But we can observe their effects on nearby matter. Observing black holes and distant objects can be challenging, and as a result, we may be missing out on discovering many of the oldest galaxies and black holes because they are not visible to us. However, with improved technology like the James Webb Space Telescope, scientists are now looking to gravitational lensing for a solution. Gravitational lensing is an effect that can make even ancient and larger black holes visible, which would help us complete our understanding of the early universe. The discovery shook the world of astronomers and cosmologists as James Webb sent photographs of ancient galaxies that shouldn't exist. These distant celestial marvels have raised questions that demand urgent answers. But that's not all the telescope's lens has focused on. The heart of galaxies revealed an ultramassive black hole possessing an unimaginable gravitational pull that dominates the center of these giant galaxies. This discovery can forever change our perception of the universe, so scientists call it the universe breaker. Using NASA telescopes, astronomers have discovered the most distant black hole ever observed in X-rays. The black hole is in an early stage of growth and has a mass similar to its host galaxy, a phenomenon never seen before. This finding may shed light on the formation of some of the first supermassive black holes in the universe. With the combining data from NASA's Chandra X-ray Observatory and NASA's James Webb Space Telescope, a team of researchers identified the distinct signature of a growing black hole just 470 million years after the Big Bang. The researchers utilized the gravitational lensing effect in the James Webb Telescope, which acts as a magnifying glass to enhance the light and X-rays emitted by the galaxy and its supermassive black hole. The black hole was located in a galaxy called UHZ-1 within the Abell 2744 galaxy cluster, situated 3.5 billion light-years away from Earth. However, the Webb data revealed that the galaxy itself is much more distant, at 13.2 billion light-years away. When the universe was just 3% of its current age, Webb managed to capture images of these ancient galaxies as they appeared over 13 billion years ago. Observations with the Chandra telescope over a 2-year period confirmed the presence of intense superheated X-ray emitting gas in the galaxy, a characteristic associated with a growing supermassive black hole. This discovery is significant in understanding how supermassive black holes can attain enormous masses soon after the Big Bang. The researchers are investigating whether these black holes form directly from the collapse of massive gas clouds, resulting in black holes weighing between 10,000 and 100,000 times the mass of the Sun. The team, led by A.O.S. Bogdan of the Center for Astrophysics, Harvard, found strong evidence that the newly discovered black hole was born massive, with an estimated mass between 10 and 100 million times that of the Sun. This mass range aligns with the total mass of the stars in the galaxy. In contrast to black holes in nearby galaxies, which typically contain only about 0.1% of their host galaxy's star mass, the large mass of this young black hole, its X-ray emissions, and the brightness of the galaxy detected by Webb support theoretical predictions made in 2017 by co-author Priyam Vadanatarajan of Yale University, suggesting the existence of an outsized black hole formed directly from the collapse of a massive gas cloud. As much as this is interesting, it is not entirely good news for our beloved universe. Can alien civilizations use black holes as quantum computers? In recent news, scientists announced that the James Webb Telescope has made 2 groundbreaking discoveries this year regarding black holes. The first revealed something massive and unknown being pulled into the black hole at the center of our galaxy. The second discovery is even more astonishing: advanced alien civilizations are utilizing black holes as quantum computers. These 2 discoveries were made at the same time, leading researchers to speculate that they might be connected. Scientists found a massive object moving towards the center of our galaxy's black hole. This object was initially speculated to be an alien spaceship involved in quantum computing. However, it was later determined to be a large cloud of dust and gas called X7. X7 is about 50 times the size of Earth and has been stretched by the black hole's gravity. It is on a trajectory towards the black hole and is predicted to eventually align with it. While the connection between the massive object X7 and the potential use of black holes as quantum computers is not explicitly mentioned, it is implied that the discovery of X7 sparked speculation about alien involvement in quantum computing. It is important to note that when we talk about aliens and quantum computers, we are not imagining comical aliens sitting in front of a black hole surfing the internet. Quantum computing is a complex scientific concept that involves harnessing the properties of quantum mechanics for advanced computational tasks. Black holes have fascinated scientists ever since Albert Einstein predicted their existence in his theory of general relativity. These cosmic giants, characterized by extreme gravity, have captured our imagination. They defy the laws of physics in ways that we still don't fully understand. Contrary to previous assumptions, the telescope has revealed that black holes were more abundant and massive in the early universe than we initially thought. Until now, researchers believed that black holes formed when massive stars collapsed at the end of their life cycle, resulting in a point in space where gravitational forces become infinite. However, the discoveries made by the James Webb Telescope challenged this understanding. It suggests that galaxies containing black holes must have existed before the Big Bang, raising questions about the age of our universe or the formation of black holes. The James Webb Space Telescope has also uncovered 6 galaxies that provide evidence of the universe's diversity and complexity. These galaxies represent a colorful cosmic dance, showcasing the beauty of the cosmos. However, amidst this beauty, black holes emerge as voracious monsters that devour everything around them with their unimaginable gravity. If black holes were once dead stars that grew in size by consuming matter or merging with other black holes, it would have taken millions or billions of years for them to reach their current enormity. It is important to note that the discovered galaxies existed approximately 13.6 billion years ago, which means the Big Bang should have occurred 200 million years before the existence of these galaxies. This inconsistency challenges our understanding of black holes, star formation, and galaxy formation. This has not only proven the existing Big Bang theory to be a mere speculation but has left scientists in fear of what this holds for the future of the universe. What does the existence of black holes mean for our universe? Scientists fear that this could be the beginning of the end. The presence of supermassive black holes at the center of galaxies is a fascinating phenomenon that has far-reaching implications for the development and evolution of galaxies. These black holes are incredibly massive, with millions or even billions of times the mass of our Sun, and their gravitational pull is so strong that it affects the surrounding stars, gas, and other celestial objects. Supermassive black holes play a crucial role in shaping the process of star formation and the growth of galaxies. When matter, such as stars and gas, comes within the gravitational reach of a supermassive black hole, it undergoes a process called accretion. Accretion refers to the gravitational attraction that pulls matter into the black hole. As the matter falls towards the black hole, it forms a disk, a swirling disk composed of hot gas and dust that surrounds the black hole. This disk is subjected to intense gravitational forces and friction, causing it to heat up to extreme temperatures. The extreme heat leads to the emission of powerful jets and winds of energetic particles from the accretion disk. The jets and winds emitted by the accretion disk can have a profound impact on the surrounding environment. One of their effects is that they heat up the gas present in the galaxy. By heating the gas, the jets and winds prevent it from cooling and collapsing to form new stars. This suppression of star formation has significant implications for the overall structure and evolution of the galaxy. The regulation of star formation by supermassive black holes is a delicate balance. On one hand, the accretion process provides a source of energy that can inhibit the collapse of gas clouds and prevent the formation of new stars. On the other hand, the jets and winds can also trigger the formation of stars in other regions of the galaxy. The interplay between these processes determines the rate at which new stars are formed and influences the growth of both the central black hole and the galaxy itself. The activity of supermassive black holes is also thought to have a feedback effect on the galaxy. The energy released by the accretion process can drive powerful outflows that expel gas from the galaxy. These outflows can remove gas that would otherwise be available for future star formation. They can also transport heavy elements and other materials generated by the black hole back into the galaxy, enriching the interstellar medium and influencing the composition of future generations of stars. Scientists have proposed various theories to explain how supermassive black holes form and grow. One prominent theory suggests that massive gas clouds in the early universe directly collapsed under their gravity, forming supermassive black holes. These gas clouds, primarily composed of hydrogen and helium, bypassed star formation and underwent gravitational collapse, resulting in the formation of supermassive black holes. Another theory proposes that supermassive black holes grow by accreting smaller black holes or stellar mass black holes. As black holes consume surrounding matter, their mass increases through a process of mergers and continued accretion. Black holes can accumulate enough mass to become supermassive. The merging of galaxies is also believed to play a significant role in the formation of supermassive black holes. When two galaxies collide, their central black holes can spiral towards each other and eventually merge, resulting in the formation of a more massive black hole. In densely populated regions of galaxies, runaway stellar collisions can occur, leading to the production of massive stellar objects or stellar clusters. These objects or clusters can eventually collapse under their gravity, giving rise to supermassive black holes. Additionally, some theories propose that supermassive black holes originated shortly after the Big Bang in the primordial universe. These hypothetical black holes, known as primordial black holes, would have formed due to extreme density fluctuations in the early universe. Subsequent accretion of mass would have allowed these primordial black holes to grow into supermassive black holes. These theories suggest that the extreme conditions during the early universe could have allowed for the rapid formation of black holes, bypassing the need for the lengthy stellar evolution process. However, it's essential to emphasize that scientific research and observations are ongoing, and our understanding of the universe continues to evolve. Scientists are actively studying the behavior of supermassive black holes, galaxy mergers, and the overall structure of the cosmos.